Okay, now let's take another function. It looks like the previous question, but there is a change here. Previously it is minus x square, here it is plus x square. So what is the method? Same thing, you have to convert it into a perfect square form. So previously it is minus, you got x square minus 1 by 2 whole square. Here it is plus, so you will get x square plus 1 by 2 whole square plus 3 by 4. Now here again, the least possible value of this perfect square is how much? You may say it is 0, but let's try. Can it become 0? X square plus 1 by 2 equal to 0. That implies x square is minus 1 by 2. X square is minus 1 by 2. Is this possible? It's not possible, right? So that means now you have to search out for some other value other than 0. So x square plus 1 by 2 whole square should be minimum. Now let's focus on first the term inside the square, which is x square plus 1 by 2. In order for the whole square to be minimum, first you have to minimize this one. Now how do you minimize this one? What is the least possible value of this expression? This will be least when x square is least. X square should be least, correct? When is x square least? When x is 0, simple. So the least possible value of this expression is 1 by 2. So the overall expression's least value will become 1 by 2 whole square plus 3 by 4, that is 1 by 4 plus 3 by 4, it's 1. So the least possible value of the function is 1 and the highest possible value is infinity. So the range will be closed interval 1 to open interval infinity. Okay, let's do another function. F of x equal to 4x power 4 minus 3x cube plus 2x square minus 1. Now this is little complicated because if you have only x power 4 and x square, you can use perfect square method, but here you have x cube also. So the only hope is you have to resort to calculus. Okay, now in calculus we learned that in differentiation chapter, what is the derivative of a function? Derivative of a function is nothing but it's a slope of the tangent at a particular point, correct? We discussed this, right? Suppose if you have some function like this, let's say at this point if you draw tangent, its slope will be nothing but dy by dx or whatever, d by dx of f of x at that particular point. When you do differentiation of f of x and you substitute that particular x value, you will get the slope of the tangent. Now what about this point? Here if you see, the tangent will be horizontal, correct? Tangent will be horizontal. What does it mean? Slope of the tangent will be how much? For horizontal line the slope is 0. That means if you differentiate the function and you put x equal to this particular coordinate, this particular point's x coordinate, you will get the final output as 0, correct? That means if I have, let's say, some function like x square minus 1, right? So the graph will be like this, somewhat like this, x square minus 1. Now if I want to find at which point the slope is 0, all I need to do is just differentiate this, that is 2x, correct? And I should equate this expression to 0. what will I get? X equal to 0, correct? So this bottommost point x coordinate is 0, and what is this point? Put x equal to 0, you will get 0 minus 1, that is minus 1. So its points coordinates are 0 comma minus 1. So this is how you find the point at which the slope of the tangent is 0. Now what is the why we are interested in finding out the points at which the slope is 0? Because for polynomials, any polynomial you take, suppose if the polynomial is like this, if it goes from minus infinity to infinity, there is no problem, range you can easily find out. But if it is going to plus infinity to infinity, then there is a problem, right? Because we don't know how will the function will behave in between. So it may behave like this, or it may behave very simple manner like this, correct? So in either case, where do you get the minimum value? At the minimum value, if you draw tangent, its slope will be 0, right? Here also if you draw the tangent, its slope will be 0. Here also if you draw a tangent, slope will be 0. So in order to find out the minimum possible value for such functions which goes from infinity to infinity, we need to find the points at which the slope becomes 0. Suppose in this case, for this complicated curve over here, you have how many points where the slope is becoming 0? 1, 2 and 3, correct? So what you have to do, you should find out those 3 points and you just find the corresponding y values. If you find the corresponding y values, you will get 3 y values, out of which one will be the least, so that will become the minimum value of the overall function, and maximum value will be, as usual, it will be infinity. So in this way we can find range of the polynomial function. Okay, so that's why it's important to find out the points at which the slope is 0. So now let's do for this function. What is the function? 4x power 4 minus 3x cube plus 2x square minus 1. Okay, so let's try to draw the graph first. At minus infinity, it will be infinity because it is x power 4, it will dominate. X power 4 is minus infinity, power 4 is infinity, so it will start over here, and at infinity it will go to infinity, so it will end over here. We don't know what is going to happen in between. Okay, from here to here we don't know what is going to happen. For that you need to differentiate the function. So you have 4x power 4 minus 3x cube plus 2x square minus 1. Now differentiate it. F dash of x equal to 16x cube minus 9x square plus 4x. Good thing about this is you got a cubic equation, but it can be easily factorized because there is no constant term here. You can easily take x common. You will get 16x square minus 9x plus 4. So you need to find the values of x at which f dash of x is 0. The slope is 0. So equate it to 0. What you will get? That implies x equal to 0 or 16x square minus 9x plus 4 equal to 0. Correct. Now you tell what will happen here. That means at x equal to 0, slope is 0. Perfect. At this point, so what is the point? X coordinate is 0, y coordinate will be how much? For that you need to put x equal to 0 in the original expression. So if you put x equal to 0 here, you will get y value as minus 1. So the point is 0 comma minus 1. At this point slope is 0. Now you solve the same you solve this quadratic equation before solving you can easily see that this 16 and 4 are very big numbers, and 9 is like it may get dominated by these two, right? So let's find the discriminant first. Discriminant is how much? B square minus 4ac, that is 9 square 81 minus 4 into 16 into 4. So obviously this will be less than 0, right? Because this is 64 into 4, that will be greater than 81. So discriminant is less than 0 means you will not get any real roots. That means you have only one value of x at which f dash of x is 0. So f dash of x is 0 only for x equal to 0. Okay, so that means only at this point the slope is 0. So you try to draw the graph, you will get like this. At 0 it is minus 1, somewhere here. If you want to draw a graph more accurately, you need to take some more important points. So put x equal to 1, what you will get? For x equal to 1, you will get 4 minus 3 plus 2 minus 1, that is 2. Put x equal to minus 1, what you will get? 4 plus 3 plus 2 minus 1, that is how much? 8, right? 8, you will get 8. So at 0 comma minus 1, which is this point, 0 comma minus 1, you should get this shape. So this should be 0 comma minus 1, should be like this. Should get a bowl shape, cup shape. So if you draw the graph, it will be somewhat like this. We have taken scale differently. So if you take scale normally like 1:1 scale, then you will get a different look for the graph. But essentially the basic features will be same in either case. Basically the tangent will be 0 here. So the range will be how much? Range will be least value is how much? Least value of y is minus 1. So the range will be minus 1 to infinity. Okay. So, and what you can say about the roots? Now this, if someone asks, range is okay, range is minus 1 to infinity. Now if someone asks, find the number of roots of this particular equation, that you can easily tell from the graph, right? So at how many values of x the y value is becoming 0? Y value 0 means the point should lie on x-axis. So that point should lie on this curve as well as on the x-axis. So point of intersection of the curve with x-axis is nothing but the roots of this equation. So at how many points it's intersecting? This is one point. Okay, so if I zoom it, you will get this as 1 point and this as the other point. So you will get two roots. One root is in between minus 1 to 0 and the other root is in between 0 to 1. So lot of information you can obtain. That is the benefit of the graphs. Okay.